right, part D. Now we got another train. Train B is traveling north. So this one's going north-south, and the other train was going east-west. All right, the velocity of the train is given by this quadratic at time t equals 2. The train is 400 meters north of the station. So we had t equals 2 in the last problem for the train A. We knew it was 300 meters down the road. Now we know this one's 400 meters up the road. Find the rate at which the distance between the trains is changing at time t equals 2. Ooh, looks like a related rate to me. All right, let's see. Oh, we got so much going on in here. Hold on, let me get rid of everything. So there's A, there's B. We think he's going north. We have to find out what the velocity is, see if it's positive or negative. Positive, it's going to be going north. Negative, it's going to be going south. So let's see. All right, first things first. At t equals 2, 300 meters this way, 400 meters that way. Makes a right triangle. Oh, 3, 4. It's a 3, 4, 5. So the distance, I'm calling it Z over here, the dashed line is 500 meters at time t equals 2. All right, we're probably going to need that. Let's see. We need a thing that relates the pieces together, and that would be that Pythagorean theorem. So x squared plus y squared, if I call this x and I call this y, and I call that z, we have x squared plus y squared equals z squared. All right, we're taking the derivative in regards to time. So don't forget, you're doing a dt. Now that's x squared, and that's y squared, and that's z squared. So nobody's in agreement. So everybody's going to have the tag along. So you're going to have that dx dt, the dy dt, and the dz dt over here. Okay, taking derivatives. Derivative of x squared, 2x dx dt. Derivative of y regards to t is 2y dy dt. And finally, 2z dz dt. Again, see the 2's in each one, so I can divide by 2, both sides by 2, and make those all go away. So I'm left with my function that relates everything. X dx dt plus y dy dt equals z dz dt. We already figured out x and y and z. That's the 300, the 400, and the 500. The dx dt, that is coming from a table, and the table tells me it was 100 at, so right there, at time t equals 2, my velocity for train A is 100. That's going in here. Dy dt. All right, they gave me a function over here for what the velocity is, so I got to plug in that 2. And when I plug in the 2, let's see, 2 squared, 4 times negative 5, negative 20. And then 60 times 2, so there's the 120, and then the 25 at the end. 120 and negative 20 gives me 100, plus the 25, 125. So my dy dt, how fast? It's moving north because it's positive. It's moving north at 125 meters per second. Put that right in over here for dy dt. All right, now we got 500 dz dt. dz dt is the thing we're trying to find out. How fast are they moving apart? We got 300 times 100, that's 30,000. And then we got 400 times 125, that's going to give me 50,000. You guys are going to have calculators, so this shouldn't be an issue. 30,000, and then we got to divide by 500 over here. It'll get me dzt by itself. And that's 80,000 divided by 500. Cancel a couple of zeros, 5, and you get the 160 meters per minute. Yeah. Give me a second, and we're going to figure out the scoring.